Here we are, Computer Concepts Module 4, Part 2 of Operating System and File Management. So what we're going to cover here is describing the purpose of an operating system. We're going to briefly look at memory again. We've already covered it, so we won't cover that in a lot of detail. We'll look at the steps to booting a computer and how the operating system manages input and output. So now that we know what the input and output are, okay? So the purpose of an operating system is just that. It's to operate the hardware that's within a computing device. Now, notice I said within a computing device. Your smart TV has an operating system. It manages the CPU, the memory, the display, all of that stuff. Here we're primarily talking about computers. So if you notice at the lower level here, CPU, memory, devices, those are peripherals. That might be a video card that you've put in, a sound card that you've put in, or a special peripheral. Then there's the kernel, okay, which we can think of as a portion of the operating system. It is responsible for the management. It is where the operating system lies. And then, of course, applications that the operating system runs in order to take advantage of the CPU, memory, storage, etc., so that we're productive on a computing device. So keep in mind that even your smart TV most likely has a Linux or Unix, most likely Linux, operating system that is running it. So just a quick, very brief reminder of memory. Memory, of course, is volatile. We talked about that previously. You take the power off of memory, we lose what's in it unless it's ROM, read-only memory. And then now we can flash that ROM, but it's always read-only, okay? RAM, random access memory, of course, the cache, which is the temporary storage. We see, temporary caching of file system properties. We see cache within the CPU, etc. Virtual memory, we've talked about that. It's what goes out to the hard drive if we run out of RAM, for example. And then we have covered flash memory, I think, enough. So let's look at the steps in the boot process. So to boot a computer, first of all, there's this idea of the power on self-test, okay? If you notice, that's in the middle there, POST, power on self-test. And that's what happens when that BIOS kicks in, okay? But before that, of course, we have to supply it power. We hit the magic power button. The power supply, which, by the way, in a desktop, well, and on a laptop too, has different wires with different voltages for different things on the motherboard. So it's imperative that you understand that a power supply, it's easier to see on a desktop because all the different colored wires that are attaching to the board are delivering different voltages to that board, okay? And it's AC to DC. The bootstrap happens, so referred to a bootstrap or load button, okay, that was used to initiate hardware boot program, or now that's seamless within the motherboard, within the power on self-test. You've got the power on self-test, which is going to make sure, hey, do I have the hardware components I expect in order for the operating system to run? Do I have a CPU? Do I have memory installed? If you want to know what I mean, pull the memory out of your computer and see what happens. First of all, it'll fail the POST, the power on self-test, and you'll get a beep code that says, hey, I'm missing a main component to operate this computer. At that point, it'll load the OS, your operating system, usually loading it from a secondary storage device, most likely what we refer to as the C drive or the hard drive. And then, of course, the computer loads the system configuration and loads startup programs. So any programs that we have in the startup, it's going to run. It's going to run the services that are needed for the OS and any program that we say, hey, when the computer starts up, go ahead and start that up. Now, let me give you a little hint here, folks. In that startup can be a lot of services like from HP saying, hey, check if there's a new driver. Hey, check if there's a new driver. Those are all using resources. So you want to look through those, you want to research those out on the web and turn them off because they're using system resources. That's my opinion. If you've got a powerful computer and you're not worried about resources, leave them on. That way the software gets updated frequently so that there's not this, what should I call it? This drain, if you will, on computing.